then let's focus on how can we characterize the electromagnetic emission that is coupling out of one of the IC pins. Last time we said, oh, it's very simple. We can probe with an oscilloscope probe directly at the pin, measure the noise signal that is present at this pin and transfer it into the frequency domain. Yeah, very simple. But there is another idea that comes mainly from the VDE, Verein Deutscher Elektrotechniker. They said that if you are characterizing the electromagnetic emission of a whole system, then very often, as I mentioned, it's the cable harness that is acting as a transmitting antenna. And then we are measuring in a certain distance, 5 meters, with an antenna, the radiation that comes out of the loop from the cable harness. And they came to the conclusion that it would make sense to also measure the electromagnetic emission that is coming out of one specific IC pin, more or less in the same way, but without the cable and without the coupling to the antenna. Because the cable is very it's very difficult to make reproducible measurements when you're measuring the electromagnetic emission in 5-meter distance from a cable. Because every time you're changing mechanically the cable a little bit, you're changing also the coupling to the antenna, and this is not very reproducible. So their idea was, hey, what about if we are not connecting a cable to the pin, we are just connecting an equivalent impedance that represents exactly the same antenna impedance as the cable. Okay, then they made quite a lot of investigations. How big is the typical antenna impedance of a cable? When it's used, for example, in the automotive environment, I have a control unit, there is an IC in the control unit, and at the control unit there is a cable harness. So what is the impedance that the IC sees when she looks into the cable harness? They made quite a lot of investigations, and they figured out that the typical antenna impedance is about 150 ohm. Not all exactly 150 ohm at all frequency ranges, but somehow in average, it's somehow 150 ohm. And then they came to the idea, okay, then let's define a network consisting of passive components, which is exactly defining 150 ohm. And this network is then connected to the IC pin. They're just simple components. They can be placed in a very reproducible way, and then we can characterize the electromagnetic emission of the IC. And this was then realized in the so-called 150 ohm measurement technique, where they are placing really a 150 ohm antenna impedance at the pin of an IC. Okay. And at the same time, they were also thinking that most of the electromagnetic emission should be we should be able to measure most of the electromagnetic emission at the power supply. Why? Because this is where the current flows in and flows out of the IC. And they really had the idea that all the currents are flowing somehow into the IC by the input pins and flowing out of the IC by the ground pin. So the ground pin must be the location where all the juice is summarized and flowing out of the IC. So this is the ideal location to measure the electromagnetic emission, which is somehow true, but not always true in general. So they came to the idea that we can also characterize the emission of the integrated circuit by measuring at the ground path. And there we can place a current probe to measure the current that is flowing really into the ground.